In this video I'll show how to find any term in a binomial expansion without finding every single term. Now first, we've seen before that Pascal's triangle can be expressed as a series of combinations. So here we have the fourth row of Pascal's triangle, can be written as these combinations. Once again, to work out this expression here, can be also written as C42, which is going to be 4 factorial the first two terms, so 4 times by 3 divided by the 2 factorial, and we end up with 12 divided by 2, we end up with 6. So those two terms are the same as each other. And we've seen that the expansion of a plus b to the power of n is going to equal, well, we've got first up our c n0, then a to the power of n take 0 times by b to the power of 0. Then my next term would be the combination, so c n1, then a to the power of 1 less than n times by b to the power of 1. So once again, the powers on b are increasing while the powers on a are decreasing. So this pattern continues. So if we find some term in the middle, we're going to have the combination c n r, then the a power will be n minus r, and multiplied by b to the power of r. So notice that the power here is the difference of those two terms. Likewise, power, difference of those two, power, difference of those two there. While the power on the second term is that base number there. So power of 1, base number 1, base number r, power of r there. So this here is the general term. So when we have all of these terms here, this is term number 1, this is term 2, this is term 3. So in the second term, then the base number here is 1 less than the term number. Likewise, in this term 3 here, the base number is 2. This would be term 4 here, the base number is always 1 less than the term number. So if we consider the general term as term r plus 1, then my combination here will be Cn, our power is n, and the base number is 1 less than our term number here, so it's going to be Cnr. And then my first term will be a raised to the power of the difference of n and r, so a to the power of n take r, and then the b term will be raised to the power of this base number here, so b to the power of r. So that formula is the formula for the general term in a binomial expansion. Alright, in this example I'll write down the first 3 and last 2 terms of the expansion of this bracket. So my first term will be C12, which is 1 times by 2x to the power of 12, then multiplied by 1 on x to the power of 0, which is be 1, plus my next term will be C12, 1, which in fact is equal to 12, times by 2x to the power of 12 take away 1, and then multiplied by 1 on x to the power of 1. Once again, the power here is the same as the base number there. And the power here is the difference of those two numbers there. And my next term will be C12, 2, then 2x to the power of 12 take 2, times by 1 on x to the power of 2. Right, and then the last two terms, well, the second to last term will be C12, 11, and then the 2x is raised to the power of 12 take 11, and the 1 on x is to the power of 11. And my final term will be C12, 12, which in fact equals 1, and then 2x to the power of 0, and then 1 on x to the power of 12. Second example, I'm going to find the seventh term in this expansion. So term number 7 would equal the combination C14, and this base number here is 1 less than our term number, so it'll be 6. Multiply this by 3x to the power of 14 take 6, which is 8, and multiply by negative 4 on x squared to the power of 6. Another thing to look out for is that these two powers should always add up to make the maximum power of this expansion of 14. And here's the final example. So in part A, I want the coefficient of the x power 6 term. So first up, work out the general term. So term r plus 1 equals the combination 12r, and then x squared to the power of 12 take r multiplied by 4 on x to the power of r. Now if I want the x power 6 term, I need to get these x terms together as one term. So I need to simplify. So the x squared raised to the power of 12 take r, those powers multiply. I'll get 24 take 2r, and this fraction, both parts of the fraction get the power of r, and now I'm dividing x's, therefore I can take away their powers, and so I'll have 24 take 2r take another r, so 24 take 3r will be the power on the x. Now we want that power, 24 take 3r, to equal 6. So if we let 24 take 3r equal 6, we solve that, we will get r is equal to 6 will be my answer for r. And so now the coefficient I'm after, well, that term there is the coefficient. All I have to do is let r equal 6. So the coefficient will be C12, 6 multiplied by 4 to the power of 6, which we can simplify in the calculator and gives us an answer of that massive number. And part B, we need to work out the constant term. So the constant term is when the x is power 0. So once again we let the power 24 take 3r equals 0, and if we solve that we'll get r is equal to 8, and therefore my constant term, I will let r equal 8 in that expression there again. Alright, so the constant is going to be C12, 8 and 4 to the power of 8, and once again that can be found on the calculator.